Hello everyone. Let's see the first problem from our CodeForces round 855. That is it a cat? In this problem, we will be given a string, okay? And our string should be of a particular form. What is that? Our string should always start with an M, capital or smaller, lowercase or uppercase, doesn't matter, okay? Sequence of M, okay? Followed by non-empty sequence of E's, which will be followed by non-empty sequence of O's, okay, and at the end which will be followed by a non-empty sequence of W's, okay. So if we see M E O W, M followed by E followed by O followed by W, M's followed by E's followed by O followed by W. Similarly here M E O's and W, okay. If our string is of this form, then this is a call by a cat, okay. If our string is of this form, we are supposed to return yes. Otherwise, if our string doesn't match this form, we will simply return a no, okay. Determine whether the sound you heard was a cat mewing or something else, okay. Let's say this is our given string, okay. Our string should be of the form meow, right? Okay, so at the very first step, we will convert this string to all lower cases: m e o o o o and w, okay. Because if a particular character is uppercase or lowercase doesn't actually matter, okay. So we will convert all of them to lowercase. Now what we will do, we will now try to remove all these occurrences and convert them to a single character, okay. So if we remove all the occurrences, our string would be something like this, okay. So how to do that? We will convert this string into a array of characters. Let's assume this is an array of characters, okay. Now we will put a pointer here and we will keep a character called previous, okay, which will let us know what our previous character was, okay. Let's initialize it to say 0. This is 0, okay, not O, okay. So now what we will do, if current character is not equals to previous character, okay, what we will do, in this position, kth position, we will put the current character. We will move k, move up k, okay. Now we are here and our previous would become the current character, okay. Is the current character equal to our previous character? No, it is not. We'll put the current character to our kth position, okay. Our previous character now becomes E. We move up, right? This one also moves up, okay. Is our current character equal to the previous character? No. We will put this current character here, okay. And we will move k here. We will update our previous to our current character. We'll move up. Is our current character equal to the previous character? Yes, it is equal. Okay, we will skip. Is it equal? Yes, still equal. Skip. Is it equal? Yes, equal. Still skip. Now, we finally have found a different character. W is not equals to O. So, in this kth position, we will put this W. Okay. And we will move K here. Okay, our previous character becomes W. Now, we come here, we move out of bounds. So, finally, we have achieved this array. We have modified our array of characters to this. Now what we will do, we will extract this part, okay. We have reduced our string to our mu form, okay, not exactly mu form, I mean we have removed all the duplicacies and converted them to one single characters, right? Yet we have converted them to like this, okay. Now we will extract this meow. If this string is equal to our format meow, then we return a yes, otherwise we return a no. We print basically, okay. Let's say this is our string, okay. We'll have k here, our previous is equals to 0, say, okay. We are currently here. Is current character equals to our previous character? No. Put the current character at the kth position, move k forward, we come here, our previous character becomes our current character, that is m. Is the current character same as the previous character? Yes, it's same. Skip. Is the current character same as the previous character? No. At the kth position, put the current character, previous becomes our current character, k moves ahead, and we also move ahead. Is the current character same as the previous? Yes. Skip. Current same as the previous? Yes. Skip. Current same as the previous? No. At the kth position, put the current character, move up, previous becomes our current, okay. Is the current character same as the previous character? No. At the kth position, put the current character, okay. This one becomes our current. K moves up, then we go ahead, we move out of bounds. Okay, then we will extract this. That is MEUW. Is it equals to our MEOW format? No, it's not. We return no. Okay, so this is the code for our approach. We input n, we input the string, then we convert it to all lowercase, we convert it to a character array. We initialize previous to a dummy character, and we initially put this k pointer to at the 0th position. Now we will iterate over the character array. Okay, if current character is equal to the, if is not equal to the previous character, then we will put the current character at the kth position, and we will move up k by 1 position. Okay, and our previous will become the current character. So this for loop will run till we move out of bounds. Now we will finally get the string from 0 to kth position, right? We first convert it to string, then we, using substring method, we extract the string from 0 to k minus 1 position, right? Now we check the format. If our string is equal to mu, then output a yes, otherwise output a no. All right, let's look at the second problem. Christina would be given a string of length n. Okay, now for each pair in the string, which type of pair? A pair of same characters, one would be uppercase, one would be lowercase. For that particular type of a pair, Christina would get 1 point, okay, or 1 bird. Okay, so how many points can she earn? So if we see her here, this small a capital A gives her 1 point, this capital B small b gives her 1 point, capital C small c gives her 1 point, this capital A small a gives her 1 more point, so 4 points. Okay, now the thing is, she would be given a number k, which is number of operations which she can perform on the given string s. What type of operation? She can perform an operation in such a way that, if we see here, this a and a formed a pair, this a and a formed a pair, this b and b formed a pair, c formed a pair, e doesn't have any pair. Okay, this a and a are in pairs, but one is, both are in small letters, right? So the operation she can do is, she can convert a character to uppercase. So if we see this given example, we get 1, this and this gives us a 1, this and this gives us a 1, this and this gives us a 1. This e doesn't have anything to form a pair with, and this can form a potential pair, and we have k given as 2. Okay, so she would perform one operation to convert this a to a. Okay, from which she will get one more pair. Okay, so number of points she can achieve is 5. Is it? Yes, 5. So what are we going to do? We are going to record the frequencies of these lowercase and uppercase characters. Okay, we'll have two separate maps for that. So for a, the frequency is 1 2 3 4 4. For a it's 1 2, okay, 2. For b it's 1. For small b it's 1. For capital C it's 1. For small c it's 1. Let's we will also have e, but that's not going to help us, so let's just ignore it. Okay, so we can see this 1 and 1 formed a pair, this 1 and 1 formed a pair, and among these 4 and 2, this 2 and 2 from this 4 formed a pair. Okay, and we are left with 2 more, right? Exactly, 2 more. Okay, now out of these 2, how many can Christina turn to a uppercase or lowercase? So if we have these 2, she can turn this one to an uppercase, right? That is by 2. Say we had 4 a's, right? So in that case she would turn 2 a's to uppercase and the rest would remain lowercase. Or let's say she had all uppercases, so she would turn two uppercases to lowercases, and 2 uppercases would remain as it is. So they both will form pairs. Okay, and she would get 1 point for each of them, right? So in this case we can see Christina performed 2 operations, but the thing is, we are given k, right? We can perform k operations. Okay, let's say k is 1, so she won't be able to perform these 2 operations. She will have to perform only 1. Otherwise, say k is 3, so she needs to perform these two operations, she would perform it, right? So it totally depends whichever is the minimum, the number of operations she needs to perform, or the number of operations she is permitted to perform. Okay, so after we perform an operation, okay, we will, let's say we perform two operations, we will simply subtract this number of operations from our k was 3, 3 minus 2, that is 1. We can now perform one more operation. Otherwise, let's say we want to perform two operations, but k tells us you can perform only one, so we will perform one operation and this k will become 0. That is, we are exhausted, we have performed all possible operations. Okay, we can't do anything further. So this is pretty much the intuition. This is the code. We input n, we take the input for k, and we take the input s, the string. We create two integer arrays of size 26. This one is frequency of capital letters and this is the frequency of small letters, okay, fc and fs. Now we will populate them. Okay, if the character is an uppercase, then increase the frequency in fc, otherwise increase the frequency in fs. Okay, initially our answer is going to be 0, or this or say the number of points. Okay, we will check for each character. Okay, 26 characters. This int lowercase count is going to get us the frequency of a particular character from our frequency small array, and this up count is going to get us the frequency of our corresponding capital letter, okay, from fc array. Now we saw that in this case 4 and 2 we could form this many pairs, right? And we were left with 2, right? So that is the minimum. So initially we add the minimum of the two frequencies. Okay, we can get that many points or that many pairs we can form. Okay, now if we can perform operations, that is if k is greater than 0, we will calculate the extra. What is extra? The extra number of characters that are still left. Okay, what is this extra? This is the difference between this frequency and this frequency. 4 minus 2, that is 2. We are left with 2 characters, okay, that we can change, and the number of operations we can perform is the minimum between the number of operations we are permitted to do and the half of our extra, right? Say we have 4 a's, we can change 2 a's to uppercase or lowercase, right? Therefore extra by 2, I have named it to left. Okay, so in our answer we are going to add that many operations, or each operation is going to give us 1 point, right? Each pair. And finally from k we subtract our number of operations. Okay, and at the end we print answer. Now let's see the third problem, powering the hero, easy version. Okay, there is a deck of n cards, each of which is characterized by its power. There are two types of card: a hero card which has a power of 0, and a bonus card which has a power greater than 0, always positive. Okay, you can do the following with the deck. Take a card from the top of the deck. If this card is a bonus card, you can put it on the top of your bonus deck or discard. If this card is a hero card, then the power of the top card from your bonus deck is added to his power, if not empty. After that, the hero card is added to your army and the used bonus card discards. Your task is to use such actions to gather an army with the maximum possible total power. Okay. Say these are the set of cards that we are going to be provided serially, one by one. Okay. These are the powers of each of the cards. Okay, we are provided 1 at the beginning, we put 1 in our deck, then 2, then 5, then 0. In case it's a 0, power 0 hero card, in that case we will add the power of the topmost card into the power. Okay, so power plus equals to 5. Okay, fine, we remove this, then we have a 4, then we have a 3, then we have again a 0. Okay, if we have a 0, we add this to our power, it becomes 8. Now the thing is this the maximum power achievable? Let's say we have these cards 0, 0, 4, 3, 0. Okay, we add 5 to our deck, then 2 to our deck, then 1 to our deck. We finally have a 0 in our power. We add the topmost power, that is 1. Okay, fine, remove this power, then we add 4 to our deck, then 3, then we have a 0. We remove the topmost power, we add it to our main power, we get a 4. Now is this the max power possible? No, because instead of 3, if we would have used the 4, and instead of this 1, if we would have used this 5, we could have achieved a greater power, 9. So what do we observe from this? We observe that whenever we encounter a 0, at that very moment we are supposed to have the access to our maximum power, okay, maximum power present in our deck. And what data structure can we use that in order to serve our purpose? We can use a max heap. Okay, whenever we encounter a 0, if our deck is not empty, we will extract the topmost element, topmost power, and we will add it to this main power. Okay, so let's say we have this same example, 5 4 2 1 0 3 4 0. We add 5 to our max heap. Okay, then 2, it goes below, 1, it goes below. Okay, 0, we extract the topmost power, that is 5, add it to our main power, remove. Then we have 3, add it. Okay, 4, add it here, it's the max. 0, okay, remove the topmost, that is 5 plus 4 equals to 9. Okay, so this is going to be our approach. So this is the code. We input n, we take the sequence of our powers, right? Okay, we initialize our max heap. Okay, and we have our power variable. So we have used a long data type because our individual power can be at max 10 power 9. So if we add anything to that 10 power 9, we can overflow. So because of that, we have used a long. Okay, for int x in a, let's say x let be individual powers in our array of powers. Okay, if it's not a 0, insert it into our max heap. Otherwise, if it's a 0, then if our heap is not empty, add the topmost power to our main power. Okay, and remove it. So this poll function removes as well as returns the topmost element, and we add it to main power, then we print our power. Okay, also for our c2, that is the hard version, this is going to be the exact same code. It works. All right, same problem statement, same solution, same code, same everything. Okay, now let's look at the fifth problem, that is D, remove two letters. In this problem, we will be given a string, and in that string, we are supposed to remove each two consecutive letter. Okay, and after removing that, we are supposed to count the number of unique strings that we are going to achieve. Okay, let's say we have this AAABCC. If we remove the first two A's, we have ABCC, that is one type. Okay, we remove the second AA, we still have ABCC, no, not unique, we still have one unique string. We remove AB, we have AACC, that is another type of string, two strings. Okay, we remove BC, we get AAAC, third type. We remove the last two C's, we have AAAB, that is one more unique string, so 4. Okay, if you see here, it's AAABC, 4 strings. Okay, so we are supposed to return the number of unique strings if we remove two consecutive characters from string S. Okay, say we have this string. If we remove these two consecutive characters, we have CD. Okay, then if we remove these two, we have AD. Then if we remove these two C and D, we have AB. So that is three unique characters, three unique strings, right? So if we have a string of length n, how many two consecutive characters or how many pairs can we remove? We can remove n minus 1 pairs. Okay, we can remove n minus 1 pairs. Say we have A, B, C, D and E. How many pairs can we remove? 1, 2, 3 and 4. That is the length minus 1. Okay, and say all the characters in our string are unique. So if we have n minus 1 pairs, then the number of unique strings that we are going to achieve is also n minus 1. Okay, because we saw it here, right? This 3, if we remove AB, then BC, then CD, then DE, then we are going to achieve 4 unique strings. Okay, so by default, the number of unique strings we can achieve is going to be n minus 1. But the exception occurs when we have same consecutive characters. That's when our exception occurs, because if we remove these two, we have this ABCD. Okay, if we remove these two, we still have ABCD, right? If the length is n minus 1, we are supposed to achieve 5 unique strings, but in this case we saw that we achieve the same string twice, so this thing decreases to 4, isn't it? We have to count the unique strings. Now if we remove this, we have AAACD, right? Then we remove BC, we have AAAD, then CD we have AAAB. Okay, so how are we going to address this case? If we try to observe something, if we take these two pairs, this A is common to both pairs, right? So this A is not actually affecting us. What is actually affecting us is these two A's, right? Because if we didn't have this A, let's say we didn't have this A, then we wouldn't run into that problem, right, of duplicate strings, right? Because if we remove these A's, we have this. If we remove AB, we have ACD, right? So the problem is when we are at index say I, when the character at index I minus 1 and the character at index I plus 1 are same, that's when we are running into a problem of duplicate strings. Okay, let's check another example. Let's say A, B, A, C, D. Let's say we have this. Okay, if we remove these two, we have ACD. If we remove these two, we still have ACD. So what do we see? These two, because they are equal, it's causing us a problem. So our algorithm would be to check if we are at this index, if the previous character and the next character are same or not. If it's the same, then we will decrease our value, this value. The default value is this, right? So our value would become n minus 2. Okay, we will have n minus 2 unique strings. Say at a certain position again we encounter this situation, then our unique string will decrease n minus 3. Okay, so that's what our algorithm is going to be. I hope it's clear. So this is the solution. We input n and we input the string, and our default answer is going to be n minus 1 unique strings. Okay, we start from 1 and go to second last position, start from second position to second last position, and see if our previous and the next character are same or not. If they are same, we decrease this. Okay, we have run into a duplicate string, we will decrease this. And we, if we move further and if we again encounter this situation, then we realize that we are again running into a duplicate case, then we will again decrement this variable. At the end we will finally print this. Okay, so if you like this video, do hit the like button, share this video and subscribe to my channel if you haven't, and I will see you in the next video. Bye bye.